material there from Learning Outcomes, excuse me, from technical literacy. But technically you should know how to do that, and technically the videos should not stop you whether you can see them or not. The biggest advantage I'm about to give you is that I'm actually going to draw on a pipeline that is very similar to your pipeline. Just before you start getting too excited, I have labelled the contours up here, so they are completely wrong. So if you think that you can copy them, I wouldn't suggest that you do that. I'll just draw them in there and tweak them a bit so that they are completely wrong, but I'm going to be able to draw a long section of them for the purposes of this class. Okay. The other thing is, this is the part where the hey bro thing doesn't work, or hey bro-s, because you should all be using a different combination of triangles. Therefore your contours will be very slightly different. Therefore the long section is going to be different. Therefore the numbers down the bottom are going to be different that we do tonight. Therefore nobody's long section should be exactly the same as anybody else's, unless you're planning to win Lotto this weekend. So that said, I'm going to now give you a little bit of a demo on a long section. What I didn't do was save the assignment, because every time I haven't done that and I've said to the class, oh now what's the level of the platform, and everyone just goes, duh. I don't look at the assignments, I just film your lectures, that's all I do. So I'll do that now so I don't have to keep asking you guys, because it will be silly to follow the assignment at the same time, I guess, as that's what I'm drawing. Sarcasm is just dripping off me today. Okay, let's go to the assignment. Week 1, assignment. Here it is. Revised on the 17th of the 7th. Put that on the desktop. And open it up. So what is going to be used throughout this demonstration will be the grade, the level of the beginning, the invert level at the beginning of the pipe. This just is a check to see that it's going to end up quite deep in the wetlands. The platform level, and the fill batters and the cut batters. So we're going to be looking at all of that when we're drawing up our long section. So it does probably pay to open up the assignment, because it just gives you an idea of what you're reading and what we're about to do. So I will move that to the side because we don't need that anymore. Do I do? I'll put on my goggles because we've got that thing called age affecting me at the moment, where I have to have a $2 pair of glasses from Warehouse. Now prescription ones now. And we will get started. So I'll drop that down and we'll have a look at the file itself. So I'm going to start by doing what we normally do when we draw up a long section. So I'm drawing a line from here parallel, probably a fairly long line, it makes it a wee bit easier. And what I didn't do was copy first up. So I need to copy this to the side, because we're going to be using this one here, not the existing one. If I rotated that, all the coordinates would be wrong. So now I take the command from last semester, align. I'll grab that, enter from the first point to the first point, from the second point to the second point. No third point, so just go enter. And do we want to scale it? No. In for no, enter. So that's directly out of the Ingrid textbook of how to align it ready for your long section. That's long section. So the next step is going to be drawing lines up from your pipe. So we're going to draw a line from here, and we look at that contour. It's contour number 44. So we draw up 44, enter. We do another line from here up 44 again, enter. We do another line from here, now that's 44.5. We do another line from here up 44.5, because that's also on the same contour line. No, it's not, it's on 45. Thank you for pointing that out to me, 45. We do another line from here up, also on the 45. And we do a line from here up on 44.5. So now I'm going to join them all together. 1, 2, 3, 4, 5, 6. And then from your last year's learnings, it's simply a case of continuing that line onwards to find the ground profile. So we use the extend command. Oops. There and there. Does this bring back memories? Is everybody happy? Amazing? It's really amazing. It's amazing how 24 hours after I tell you something in the lecture, the whole lot of you have forgot, just like I said you would. What have I done wrong?
Manhole.
No? What did I say this long section is? It's stretched in the vertical direction. Yeah. Don't feel bad, last night's class forgot only in about 4 hours, so you guys have had 24 hours to forget. It's not too bad. And I'll tell you something else for nothing. Before we're out tonight, you're going to forget again and again. Last night's class did it 5 times. We'll see how many times you guys forget.
It's 5 to 1, isn't it? Stretching.
The stretch factor is a scale of 1 to 50 and 1 to 100, so it'll be 2 to 1. 2 times. Now I can get up my calculator, and where I went up 44.5, I can multiply that with 2 and get 90.1. 91, sorry. Or I'm just going to cheat this. I'm going to copy those lines up. So what I'm going to do is copy that from here up and just move these lines down so that they touch. So effectively I've doubled those lines. Do you all understand what I'm talking about? And then our new profile at the top, so we can delete this. A new profile goes from here to here to here to here to here to here to there. Right? And when we drag this one up, if we can, actually what we should have done is extended that last line because that was the correct way to do it. So we type extend, we click on the line we're extending to, enter, and then just extend those lines like that, like you were shown how to do last year. Trim that off. So we're all happy with that? Except, no, that's dead right, we are happy with that, so far that is correct. So now we're going to form a datum line, and I said to use a datum of 40. So we're going to offset 40, and before anyone goes, oh Roger, don't you double, oh sorry that was 4, don't you double that 40? The answer is yes, because I know you all are on to me now, and we're going to double that, and so we're going to offset 40 twice, and we end up with the line up there, which is our 40 line, right? So that's what we call our height of datum. So any distance up from there, we have to add on to the number 40. We'll show you about that a bit further down the line. So we've managed to do the ground profile along the pipe. But for the first time ever, we're now going to draw the pipe, okay? So, if we take a line from here, and we look at our assignment, the pipe starts at 43.75. Does anyone know what that equals twice? No? Yes? 87 point 5, isn't it? 43.75. Is that the 83?
47.5.
Yeah, 87. 87.5. Correct. Okay, so that's the start point for our. Where the hell's it gone? You had it. Okay, I'll start again. Let's do a line from here up 87.5. Here it is, I've got it. So it's that point right there is where we're starting from. Now, the grade of the pipe. Can anyone tell me what the grade is?
1.53.
1.53. So therefore, if we go along 100 and down 1.53 and then connect back up to the beginning of the pipe, the very gradual grade is represented there for the pipe. So the pipe starts here and goes slowly down on the grade down to the end, so we can chop it off at that point down here. Okay, so that's the invert level of the pipe. Everybody happy?
I did not follow that.
Yeah. Is that top line on a slope?
The top line is on the slope. It's on a slope of 1.5%. So let's. You did follow the bit where we went up to find the start of the pipe, didn't you?
Yeah.
Yeah.
Okay. So let's start from that point. So what I did was to work out a percentage. I went along 100.
Oh, right.
Okay, and then down 1.53, and then back to that beginning point. So I made a triangle. And then I deleted those 2 points there, and that's the perfect slope for the pipe. And of course the pipe ends at the end, so I trim that off. Alright? Isn't that clever?
Yeah.
I'm so clever, because not only did I do it wrong,
What?
but for the second time you guys forgot about the stretch. You don't come down 1.53, you come down
2.06.
But of course you weren't going to make that mistake too, were you? No. I might have to have a talk to your maths teacher later on after this. Along 100 and down 1.53 times 2, 3.06, right? You just said before, didn't it? 3.06. And then back up to here, so that's the true angle, the bottom one. Well, when I say the true angle, that's the distorted angle that we should be using. Okay, so how many would have done that and how many would have done what I did? Probably most of you would have done the first one. And I would have put the first one to put my hand up, the first time I ever did a distorted long section, I made all these mistakes. So I'm not saying, as I said before, I'm not invincible either. So we're looking at the pipe, we've got the pipe from here to here. So we might as well put because the pipe's got a diameter, what is the diameter of the pipe?
300.
300, yeah, but this is in meters, so what should I offset by? 0.3, yeah, and then we go up 0.3, we join up this end like this, don't forget to do that. We join the other end up from that point to there, and then, I mean, you guys can feel free to interrupt me if you want to, because I've just done it wrong again.
Yeah, it's 0.6.
It's 0.6 in the vertical direction
So it has to go up by 0.6.
by 0.6, because it's 2 times in the vertical direction. So I'll delete that.
Oh, that's the pipe.
The invert is the bottom of the pipe. Yeah, we could technically draw 2 lines because it would have a thickness, but we won't worry too much about that. Just for this long section, I'm going to offset 0.6. Now I'll just go over that again one more time. Everything in the vertical direction is distorted. Everything. So the pipe's distorted, the grade is distorted, everything's distorted. Okay? And immediately we're going to have a look at this, and we're going to see a few issues. Let's draw that on here, and let's draw that on there. Now, for those that don't understand what's happening there, the pipe is sticking out of the ground. So, normally we have a manhole about 100 mil above the pipe, then we have the thickness of the manhole lid, and then we have a lid that is placed on top of that. So when you add all that up, it's going to stick up maybe 200 above ground level. Sounds a lot, but it's only that much. But you're going to have to taper the ground down to come up to meet the manhole. Because you can't just have a manhole sticking up in the middle of nowhere, especially at Unitec. When students are texting, bang, into a manhole. So you need to gradually bring the ground up around the edge of it. So there's an issue. And I would say the site engineer which would be your level of engineering, if you were doing engineering, would be the person that would take care of that on site. Doesn't require specific design or any sort of sign off, because it's fairly low level engineering. So you should put a note saying site engineer to level the ground after the manhole is in. Now there is another issue as well. If you haven't noticed, there's another pipe coming into that manhole, and it can't come in at the same level, so it must be at least X amount below that. So I'd suggest leave another 100, and then you've got your other pipe coming in, and that will determine the depth of the manhole. Another 100 below that pipe, so it'll be 100, 300, 100, so what's that, 500, and that'll be the bottom of your manhole. Thickness of about 100, and you've drawn your manhole up. Remember the width is 1050. Okay?
What's the reason you don't just change the invert level?
Because you're not at that level of engineering where you're doing the sign off for the design. Somebody, the hire has signed the design off, a water engineer, civil engineer, whatever, has signed that off. So you're basically only as a